So glad to have all of you here. My name's Larry Bordowitz. So I'm a software engineer, I'm a developer, and I'm also kind of half DevOps. So I work on Yahoo Mail, and I work on Yahoo Mail specifically its middle tier. So what is the middle tier? That's the part that handles like API calls from desktop, mobile, IMAP, POP. So it's protocols, right? And to give you an idea of how big this middle tier project is, we have developers making hundreds of pull requests daily. By the end of the day, tens of thousands of lines of code have been changed. And this is in a code base, a Java code base that's already millions of lines of code long. So with so much code being slung around, we needed a way to keep pushing the latest fixes and the newest features. And so along the way of implementing a CD, a continuously deployed code base, we've come up with 3 principles that guide the way we build and maintain our Jenkins pipeline. So these 3 principles are version consistently, catch problems early, no humans. Thank you very much for joining the line. I'm just kidding. So let's talk about, to introduce you to our first principle, to version consistently, I want all of you to imagine that you are in a world without versioning. One developer gets really confused. So they get really confused because maybe you have multiple builds out right now, different versions for an A/B test, maybe different versions on your alpha or beta or production servers. And so how can we distinguish the production version with the latest version on the master branch? By the way, I should note that this whole thing should only be a problem to you if you don't push directly to production, and you should never push directly to production without at least internal testing. So we'll go into that a little bit in our next step to catch problems early, but for now, that's the whole motivation behind versioning consistently. The version of the code, and the version of the build, and the version of the deployed product, all those versions should be the same. And so you can do that using build numbers, or maybe you can have some stored counter on your source control. Maybe your Maven release prepare plugin, or Artifactory or Artifact, whatever. Whatever automatic, always incrementing version number you have, you can use that. And what we use is we have a latest build version on a Git tag, and we pull that out, increment it, and then put that back into Git. And we pass that through the Jenkins build using the build parameters plugin. One of the nice things about doing this is that we can always tell which version is on alphas or betas or production, and we can link that directly with our code. In SCM, it has the same version as is on the pipeline, as is on the servers. It's so nice. So all our builds are versioned, all our servers are versioned. We have the alpha with the alpha version, beta with the beta version, right? So I'm going to continue with an overview of the pipeline to show you how we catch problems early. So both of these alpha beta servers, they need to be working and validated before any code sees the light of production, right? And before it goes to alphas, we unit test it and integration test it. And then on betas, we do performance metrics tests. So those performance metrics tests round out things, and we do them twice because when it goes to alphas, it has this much, production traffic, betas, this much, and then there's gammas, but that didn't fit on the slide. So that's our main pipeline, and that's our main pipeline on a per protocol basis, but we have a lot of protocols. So we do this, and we do that for all of our protocols and services, and that's just our main pipeline. We also have a pre-review pipeline. This is also called a diff testing pipeline, I've heard it called. So for every pull request, we build and unit test it, and we also integration test it. And as we integration test it for each protocol and service, we get feedback. We get feedback for the web services integration tests. We get feedback immediately when they're done. We do them all in parallel. So that way, all our PRs are validated before they even go into the master branch. We do that 100 times per day. Maybe hundreds of times. I'm going to say hundreds of times. Can't say the exact numbers, but we do it a lot. So what if something fails? We don't live in a perfect world. Maybe something will fail. Bad code happens. It happens. It can crop up when merging the code, doing tests. For us, though, bad code never sees the light of production. And here's why. Majority of the bad code gets caught in the pre-review pipeline. We're running all the unit test integration tests. That catches most of the bad code. Sometimes, though, it slips through. And when it does slip through, it's usually caught in the main pipeline through either integration tests, performance metrics tests. Either they get fixed or they're reverted, depending on how easy it is to fix. And if it's reverted, it has to go through that pre-review pipeline again. If the bad code ends up going through that, it's usually caught in the alphas, betas, gammas when the pre-production stages, when it's actually visible to internal dog-fooded users or certain users who have opted in or who are bucketized onto these features. At this stage, the problem becomes really, really clear, and we roll back those pre-production servers so that our production servers only get squeaky clean code. So that's all in the interest of our second principle, to catch problems early. You don't want problems like a little door to nowhere or anything. So we're so invested in quality control. A pull request must pass all the unit tests and integration tests before it even gets code reviewed. And so for each class, there's a unit test class, and we have thousands of integration tests for each protocol. And 100% of our pull requests are code reviewed by at least 2 reviewers. So I can't speak for how long a code review takes. It takes long. But unit tests and integration tests all run in under an hour. By now, we're feeling pretty confident we're catching problems early, and as code moves through the pipeline, each step can happen automatically. It's really nice. There's almost no human intervention. We can just go with the flow. So an overview of the whole pipeline now. Let's have it from pre-review, when a developer submits a PR, to going to production. We use Gerrit. Gerrit's our code review and pull request, base hub. And every time a PR is made, Gerrit triggers a Jenkins job. It triggers the pre-review Jenkins job, which it unit tests and integration tests. And when that passes, it then checks, the reviewers check it. If no fewer than 2 reviewers give it the OK, it goes through to the main pipeline, where it gets versioned and built and then integration tested again. When the integration tests pass, goes into alphas, gets integration tested on more environments, more downstreams, and when that passes, goes to betas, where it's integration tested on more downstreams, has performance metrics on a sizable chunk of traffic, and when that passes, goes to gammas, where it's integration tested, and then metrics tested on an even bigger size of traffic. And once it goes through all that, then it goes into production. Now, I want you to know, in none of this, actually in only 2 steps, was there any human intervention? Was there anybody pressing a button? And they weren't even pressing a button. They were submitting a PR and they were reviewing the code. Those are the 2 steps we can't really automate writing code, although I wish it could. But those 2 steps I'm highlighting over there are the only human intervention. So that's our third principle. No humans. In that entire process, again, only human interaction. Code review process, when a request is made to merge and when the code is actually merged. So other than that, humans aren't doing anything. So everything is automatic and lovely, and actually, so I'll be honest, it's not perfect right now. There are still parts that we do manually monitor, and there are some processes that we do trigger manually. But this principle of no humans is something that we strive for, and we get closer to accomplishing it every day. Let me make a quick recap, because in each of these steps, there's a work culture change, and I want to highlight this as I go through the steps. So when we talk about new features on alphas or betas or production, we talk in terms of the build version. We can download the build version from our SCM and know it is on the alphas, betas, which feature is where. Instead of pushing bad code to users, we've inculcated a culture of caution. Once we're confident that the build works, only then does it go out to production. And we only trigger manually as a last resort. Empirical evidence trumps everything. So I want to emphasize again this underlying principle behind the 3 principles, this underlying philosophy that guides the entire way that we do CD. And that underlying principle is Jenkins does not do CD. Jenkins does not do CD. It does not do CD. A beaker doesn't do chemistry, and a microscope doesn't do biology, and a computer doesn't do computer science. And Jenkins doesn't do CD, although it's a really great tool to implement CD. CD is not something that you can install and run and just have happen. It is a work culture change. It is a cultural shift in the relationship between developers and their code, between DevOps and their code, between product managers and their code. All of that needs to shift in order to implement CD. You can have really fancy plugins. I like fancy plugins. But all of that won't help if you don't have everybody on board. Jenkins does not do CD. We do CD. Thank you very much, everybody. I'm glad you enjoyed. I hope you enjoyed this talk. We have Gopi, who's the architect of the Yahoo Mail pipeline, and the developers are Arvind, James, and myself, Larry Bordowitz. Big shout out to our sponsors, especially CloudBees, for organizing this conference and giving us the opportunity to share our love of CD with you. And thank you all for coming to this lightning talk. Really appreciate it. Thank you.